Today I'm going to be presenting to you Stray Solar and our initiatives to make a better future. Stray Solar was founded on the ideology of For a Better Future, in which we have focused on providing clean energy to underdeveloped countries where many people don't have access to clean energy for necessities in life. Stray Solar has pledged on focusing on universal access to clean energy, increasing energy efficiency, and increasing access to renewable resources in these underdeveloped countries. In 2019, Stray Solar focused on small villages across Central America that lacked the resources and support to have clean energy for basic things such as cooking. Many of these villages are required to use toxic fuels that can cause indoor air pollution to many of these households. According to the UN, indoor air pollution from using combustible fuels for household energy caused 4.3 million deaths in 2012, with women and girls accounting for 6 out of every 10 of these. Stray Solar goals focuses on affordable and clean energy. A problem we are having is to reduce the amounts of deaths caused using combustible fuels. But we have created a solution which is Stray Solar provides villages with solar-powered stoves/ovens at an affordable price. So now we're going to get into how we measure and how we're planning to implement these solutions into these villages. A derivative is a measure of how a measure is changing. It's also a numerical value that says what the rate of change of a function is for a given input. Stray Solar has partnered with many organizations in Central America that already have the resources such as workers needed to distribute the solar stoves in villages. For this reason, I've chosen derivatives in order to measure how the number of workers affect the number of solar stoves distributed. An example of real-world application of derivatives is measuring monthly sales for a business. For example, in month 1, Solar Stray sold 6,000 solar stoves. As for Solar Stray, it can also be used to calculate the marginal profit versus the number of workers currently working on distribution. So for some of our data, we're going to see that our input is the number of workers, and our output is the number of solar stoves distributed. For number of workers, we have 10, 20, 30, 40, 50, 60, and 70. And for the distribution, for 10 workers, we have 2,000. For 20 workers, we have 6,000 solar stoves. For 30, we have 8,000. For 40, we have 3,000. For 50, 10,000. For 60, we have 12,000. And for 70, we have 5,000. As we can see, as the number of workers increase, so does the distribution, but at some points, we do have a decrease of distribution. Here we can see our scatter plot with a regression. Here's our regression equation. Y equals 82.14286, x plus 3285.714. As x increases of the number of workers, y increases or the number of solar stoves distributed. So here we created a real-world scenario in which we're able to implement the derivative measures into a scenario that Solar Stray created by distributing solar stoves. Here we can see the same data, and here we did a quadratic regression for this situation. So we got d of x, which is distribution, negative 3.69x squared plus 377.38x minus 1142.86. Then for part B, we can see the scatter plot with the quadratic regression we created with the data. Here we calculate what was the total distribution at 35 and 45 workers. At 35 workers, the total distribution was 7,545 solar stoves, and at 45 workers, the total distribution was 8,367 solar stoves. Then we calculated the marginal distribution at of workers 35 and 45. Here, 35 workers or marginal distribution for 35 workers is increasing by 119 solar stoves. And at 45 workers, the solar distribution for 45 workers is increasing by 45 solar stoves. The reflection through this project, I've learned more about social, economic, and environmental impacts that are occurring around the world. I learned more about these topics, specifically relating to affordable and clean energy. For social impacts, learn that many people, specifically women, are dying from indoor air pollution caused by using combustible fuels. The environmental impact in this reduction of combustible fuels being used with the effort of Stray Solar distributing solar stoves for clean air and energy. The economic impact of Solar Strait was being able to provide clean energy for villages that don't have the resources to provide themselves with electricity or any type of clean renewable energy. I also practiced and learned more about derivatives by developing my own scenario with Straight Solar and how the amount of workers impact the distribution of solar stoves to villages.